Hello everyone. Here we are going to start with the mechanism of nitration of benzene. So before we start with the mechanism, first of all we should understand it is an example of electrophilic substitution reaction. Electrophilic substitution reaction. Now whenever we talk about the nitration of benzene, it will always be carried out in presence of the nitrating mixture. So what is the reaction exactly? Benzene on reaction with concentrated HNO3 in presence of concentrated H2SO4 will undergo electrophilic substitution reaction. Hydrogen of the benzene ring is being substituted by the nitro group, and that's how the compound obtained here will be nitrobenzene plus H2O. So this is the nitration reaction. Now what is the mechanism of this reaction? As we know that for the electrophilic substitution there are three basic steps. Now what are these? First step is generation of electrophile. So the first step is electrophile generation. How the electrophile will be generated here? Here in this case the reaction will begin with the ionization of H2SO4. So this H2SO4 will dissociate or will ionize to form hydrogen ion plus HSO4 ion. So this is the first step. Now the second step is the hydrogen ion will be taking out hydroxide from the nitric acid. How can we write nitric acid? We can write it NO2OH. Now here it will be taking away this oxygen carrying the lone pair, right? So now this pair of electron will be shared with this hydrogen, and that is how this entire will be forming water molecule. So this will form water molecule and we will be left with nitronium ion. So what is the next step? Next step is that is the pair of electron is shared with this hydrogen. Only one lone pair is left now, and because oxygen has shared its pair of electron, that is why it will become positively charged and NO2. Now this positively charged oxygen will tend to withdraw the pair of electron from here. That is how this pair of electron will be shifted here, and the next step will be it will be removed in form of water and we are left with NO2 plus ion. This is the electrophile generated. We may write this step directly also. Rather than writing in the three steps, we may write it directly also. That is H ion, OH, NO2. This will be combining with this, and that's how the we can directly write it in this way, that is H2O plus NO2 plus. So that is up to you. You may write like this or you may write like this. So the first step is ionization of H2SO4. The hydrogen ion furnished by H2SO4 will be attacking on the HNO3, and that's how it will be generating the electrophile. So this nitronium ion will be acting as the electrophile. Now moving to the second step of this mechanism, what is this formation of carbocation? Formation of carbocation. Now this electrophile will be attacking on the electron rich side. What is the electron rich side? The pi bond. The pi bond is the electron rich side. So this NO2 plus will be attacking on any of these pi bond. Say for example, it is sharing this pair of electron. It is sharing this pair of electron. So that is how the carbocation formed will be like this. Rest of the two pi bonds will remain undisturbed like this, and here this pi bond is forming a bond with this NO2, and H is already present here on this, and this carbon will become positively charged because it has given its pi pair of electron. Now this positively charged carbon will be withdrawing this pi pair of electron towards itself. So the next resonating structure of this will be like this, will be undisturbed. It will remain NO2 and H. Now here this pi bond will also be undisturbed, and this pi bond is shifted here. In turn this carbon will become positively charged. Now this positively charged carbon will withdraw this pair of electron towards itself, and that's how the next structure is going to be like this. NO2 H. This pair shifted here. This pair will remain as it is. and this carbon become positively charged. Now if we see the canonical resonance hybrid of all these, so it's going to be like this: NO2H, and the pair of the positive charge is revolving from this carbon to this carbon. So that is how the carbocations are. So this is all about the carbocation formation. Now we are moving to the third step, that is deprotonation. Now, what about the deprotonation? How will it happen? Say, for example, we have this carbocation, NO2H. Here is the positive charge, and here is a double bond, here is a double bond. Now, this HSO4 minus ion will come and it will take out this proton. So this will be moving out as a proton. In turn, this pair of electron will be shifted here to make a pi bond. So what will be the next structure? The next structure is going to be this pi bond is as it is, this pi bond is as it is, and here is the pi bond formed. NO2 will remain as it is, and H is going to combine with HSO4 to regenerate H2SO4. Because H2SO4 was the catalyst, so it has to be regenerated at the end of the reaction. So this is all about the mechanism of nitration. Thank you.